Advanced Encryption Standard (AES), the most secure encryption algorithm. In today's digital age, data security is of utmost importance. With the rise of cybercrime, it has become essential to protect sensitive information from unauthorized access. One way to do this is through encryption, which involves converting plain text into a coded message that can only be deciphered with a key. Among the various encryption algorithms available, the Advanced Encryption Standard (AES) is considered the most secure. In this video, we will explore what AES is, how it works, and why it is the preferred choice for securing data. What is AES? AES is a symmetric encryption algorithm that was developed by two Belgian cryptographers, Joan Daemen and Vincent Rijmen. It was selected by the National Institute of Standards and Technology (NIST) in 2001 as the standard for encrypting sensitive data in the United States. Since then, it has become widely adopted as the preferred encryption algorithm by governments, financial institutions, and businesses around the world. How does AES work? AES uses a block cipher, which means that it encrypts data in fixed-size blocks. The size of the block can be either 128 bits, 192 bits, or 256 bits. The key used for encryption and decryption is also a fixed size, which corresponds to the block size. For example, if the block size is 128 bits, then the key size can be either 128 bits, 192 bits, or 256 bits. The encryption process involves several rounds of substitution and permutation operations on the plaintext block using a series of keys derived from the original key. Each round consists of 4 operations: subbytes, shift rows, mix columns, and add round key. These operations are designed to provide confusion and diffusion, which are two essential properties of any secure encryption algorithm. Why is AES considered secure? AES is considered secure because it has several desirable properties that make it resistant to attacks. Firstly, it has a large key size, which makes it difficult for attackers to guess the key through brute force. Secondly, it uses a complex encryption process that involves multiple rounds of substitution and permutation operations, making it resistant to differential and linear cryptanalysis. Thirdly, it has been extensively analyzed by cryptographers around the world, and no significant weaknesses have been found in the algorithm. What are the applications of AES? AES is used in various applications that require secure data transmission and storage. It is commonly used in wireless networks, virtual private networks, VPNs, and secure messaging applications. It is also used in disk encryption software such as BitLocker and FileVault to protect data stored on hard drives. Additionally, it is used in financial transactions, such as online banking and credit card transactions, to ensure that sensitive data is protected from unauthorized access. What are the limitations of AES? While AES is considered the most secure encryption algorithm, it is not without its limitations. One of the main limitations is that it is a symmetric encryption algorithm, which means that the same key is used for both encryption and decryption. This can be a problem if the key falls into the wrong hands, as the attacker can easily decrypt the data. Additionally, AES does not provide any protection against attacks on the key itself, such as side-channel attacks or fault injection attacks. How can AES be implemented? AES can be implemented in software or hardware. In software implementations, the encryption and decryption operations are performed using software libraries or modules that are integrated into the application. In hardware implementations, dedicated hardware circuits are used to perform the encryption and decryption operations, which can provide faster and more efficient processing. What are the alternatives to AES? While AES is the most widely adopted encryption algorithm, there are several alternatives available. One of the most popular alternatives is the two-fish algorithm, which was also a finalist in the NIST selection process. Other alternatives include the serpent and blowfish algorithms, which are also considered secure and have been extensively analyzed by cryptographers. Conclusion. In conclusion, AES is the most secure encryption algorithm available today. Its large key size, complex encryption process, and extensive analysis by cryptographers make it resistant to attacks, and suitable for securing sensitive data. While it is not without its limitations, it remains the preferred choice for governments, financial institutions, and businesses around the world. As technology continues to evolve, it is essential to stay up to date with the latest encryption standards and best practices to ensure that data remains secure.